So, we only got 2 days left this week. Only, let's be honest, 1.5 days left this calendar year.
Is this are we starting a new unit?
Yeah. 4.5, 4.7. We're going to handle all of 4.5 today, though. So today is just 4.5. And then 4.7 will be when we come back. What? We don't like it. Mm-hmm.
No, I like that.
Mm-hmm.
That's a great point.
Yeah. Like if this were a contract, it would be straight through.
Yeah.
All right. Okay. So today we're going to graph the remaining 4. We got 4 trig functions that we haven't graphed. We spent a lot of time with sines and cosines because of the sinusoidal curve fitting and the period or the repetition that goes through, and how you can use those to define certain scenarios. The tides, we talked about the tides. We talked about temperatures. Tomorrow we'll do an activity about the temperatures. You'll get to pick a city, and you'll come up with a sinusoidal function for that particular city. So you'll do a little research and find all that fun stuff. Okay? All right. So let's start with tangent. Okay? So we did sine and cosine. Let's do tangent next. Okay? Now, sine curves and cosine curves, those were easy to do off of the unit circle because cosine is the x-coordinates of all of the points on the unit circle, and sine is the y-coordinates of all the points on the unit circle. So those are relatively easy to graph. The downfall is now we got tangent. And tangent is what on the unit circle? Y over x, which would also be in terms of trig, sine divided by cosine. Yep. Okay. So we're going to graph all of ours today over the interval negative 2 pi to positive 2 pi. So we're going to do 1 lap normal direction and 1 lap opposite direction. So we're really going to do it around 2 spins of the unit circle. One way, one the other way. Okay? All right? So let's talk tangents. Okay? So on your paper, what I'd like you to do is I would like you to draw yourself, I would go like 5 or 6 lines vertically, and then a good space horizontally. Okay? Okay? And then leave yourself room to work too, because we're going to have to do some figuring, because we can't just look at the unit circle and just start plotting points. Okay? All right. So let's start at 0. What would the tangent of 0 degrees, 0 radians be? 0? Yeah. Because it would be our y value, which is 0, divided by our x value, which is 1. So the tangent at 0 would be 0. Okay? I would concur with that. So the tangent goes through the origin. Okay? What other values from negative 2 pi to positive 2 pi would also have a 0 value? Pi. Okay. I would agree that the tangent of pi is also 0. Other ones? Pi over 2 does not have a tangent value of 0. And the other one's from negative 2 pi to positive 2 pi. 2 pi would have a tangent value of 0. Negative pi would have a tangent value of 0. And negative 2 pi. So all of those have tangent values of 0. So let's plot those points then on there. So here would be 2 pi, here would be pi, here would be negative 2 pi, there would be positive, or excuse me, negative pi. With me so far. Okay. Let's go into quadrant 1 then. Let's pick, actually I lied. Let's not go into quadrant 1. Let's go up to pi over 2. Okay. Let's go up to pi over 2 and let's determine, whoa, tap the brakes. Let's determine at pi over 2 what the tangent value is. Somebody in the back said, mumbled something? It's undefined? Yeah, because now it's 1 over 0. And I can't divide by 0 in the math because I'm not Chuck Norris. And I don't think any of you guys are either. Because I feel like you would have roundhouse kicked me if you would have coming into the room because you saw that we were graphing. Okay? So tangent at pi over 2 is undefined. Are there any other spots from negative 2 pi to positive 2 pi where the tangent is undefined? 3 pi over 2 would also be undefined. There's 2 more. What do you got to say? Negative pi over 2. What's the other one? Negative 3 pi over 2. Now, I don't know about you, but I find it hard to graph something that doesn't exist on paper. So we can't put a point for those. So what do we put on a graph in a spot where it's undefined? What do you got, Addie? A line. What kind of line? A vertical line. What kind of vertical line? That is the Department of Redundancy department. It's an asymptote. It's what? It's a dashed line. Yep, we're going to put a vertical dashed line at all of those values because those are all vertical asymptotes. Okay? So we can put in vertical asymptotes at those positions now. Ooh, I gotta move that one. It's not halfway. That's a faux show. Now, let's talk a little bit more about vertical asymptotes. can my function say cross a vertical asymptote? Sage, that was a very good job of interpreting. Like, you didn't even stop drawing your vertical asymptotes, and your lips didn't, like your whole body didn't even move. But yet, from the other side of the room, I heard a yeah, we can. That's impressive. You could go on the road with that kind of cat. So back to you now, Sage. Can we cross the vertical asymptote? Because if we cross it, then we would be saying that undefined is an actual number, right? Okay? So we can't cross, so we gotta stay within those zones. So our one graph rows has now become 4 graphs. I would throw this down, but I can't because Schmeling already did and broke one. Okay? Oh, here's. There, see, it broke again. I know, 4 of them now. Okay? So now we gotta fill those gaps, right? Okay? Now, let's go into quadrant number 1. What's the easiest tangent value to find in quadrant number 1? Why, what is it? You just had that many fingers up. It's 1. Why is it 1? Because it's sine over cosine, right? So it's y over x. And since they're the same, anything divided by itself is 1, right? Okay? Awesome sauce. Now, let's go. What color you want to go with for 1s? Purple? You got it. Okay? So the tangent of whatever is going to equal 1, we just said at pi over 4, right? Where else is the tangent negative 2 pi to positive 2 pi? Where else is the tangent positive? Do we agree with 5 pi over 4? Yep. There's 2 more. Negative 5 pi over 4 I do not agree with. I like negative 3 pi over 4. There's 1 more. Negative 7 pi. Is that what you had said, yes? Okay. You were kind of mumbling, and I was standing right close to you, but I still couldn't hear you. Okay? So at those spots, our tangent value is positive 1. So that means here, that would mean here, that would mean here, and that would mean here. What's another easy tangent value to find? Negative 1. I'm going to go with red. Where would the tangent value be negative 1? 3 pi over 4 would work, yes. Seven pi over 4 would work. Negative pi over 4 is the same as 7 pi over 4. So that's going to work. And negative 5 pi over 4 is the same as 3 pi over 4. So that one's going to work too. Okay. So we can put those values then in on our So that would be here. That would be here. That would be here. And that would be here. Eddie, what do you think? Do we have enough points to make graphs in our 4 zones? I think we do too. I personally think that they're going to look like this. You tell me if you think the same. Well, I'm not a fan of that last one, but I'll let it slide. I got an extra wave on that third one. Agree with them looking like that? Yeah. Yeah. And that, ladies and gentlemen, is your tangent graph. What? Because there's points of discontinuity. Because now in tangent we're dividing by 0. See, in sine and cosine we were never dividing by 0. So we never had vertical asymptotes. I know. Okay? Okay? Ready for mine to be blown, Rose? Yeah? Might as well be? Alright, well let's do it. Let's switch over to cosecant now. Okay? So first off, we'll go through the same process. Okay? So first off, what is cosecant? Either in trig form or finding points on the unit circle form. Inverse of sine? Do we agree with inverse of sine? So that means that this is 1 over the sine value, or on the unit circle, it's 1 over y. Yep. So it's the reciprocal of the y value. Right? Okay. Let's start. Come on. Wouldn't go. Let's start. Oops, I almost put tangent again. Come on, Lens. We're on cosecant. What is the cosecant at 0 radians? Undefined, right? Because it's 1 over 0, which makes it be undefined. Which makes there be a what? Vertical asymptote. Okay. Where else? Negative 2 pi, positive 2 pi would be undefined in the cosecant form. Pi? Three more. 2 pi. Two more. Negative pi. One more. Negative 2 pi. So what goes there? Vertical asymptotes. Yes. So let's put in vertical asymptotes. I know. His hair's shorter than mine. I think I need a haircut. Alright, so we needed vertical asymptotes and 0, 2 pi, pi, negative 2 pi. Ooh, negative pi, I gotta move. Right? Okay? Love it. What's another good, easy to find cosecant value? Ooh, let's hold that one, because there's an even easier one than that one first. There's actually two. What? Two. One, right? One. One is easier than two. Okay? Oh no, it actually is. So where is the cosecant equal to 1? What do you got? Pi over 2? Where else? One more spot. Negative 3 pi over 2. Okay? Because that's only when sine is 1. Right? That only happens pi over 2, negative 3 pi over 2. So we can put those on our graph now. Pi over 2, negative 3 pi over 2. Second easiest cosecant value, negative 1. Where is the cosecant equal to negative 1? Was that 3 pi over 2? 3 pi over 2 and negative pi over 2. So we can put those two on there. D, now talk to me. Pi over 6 gives me a cosecant value of 2. Why does pi over 6 give me a cosecant value of positive 2? Because the sine value is 1/2, and so the 1 divided by 1/2 is 2. Okay. Where else? There's 3 more spots that gives me a cosecant value of 2. 5 pi over 6 is one of them. Negative 11 pi over 6 is one of them. And negative 7 pi over 6 is the other. On our graph, pi over 6 would be like here. 5 pi over 6 would be like there. That was a little high. Negative 7 pi over 6 would be like here. That one's a little high too. Rein it in. Negative 11 pi over 6 would be like that. Do we have enough data to fill in zones 1 and 3? Yes. What shape is going to be in those zones? Parabola. Yep. So those are going to be a parabola in those zones. What would another cosecant value be? And where would cosecant be -2? 7 pi over 6. 11 pi over 6. Negative pi over 6. Negative 5 pi over 6. Seven pi over 6 would be here. 11 pi over 6 would be there. Negative pi over 6 would be here. Negative 5 pi over 6 would be there. Do we have enough for those for zones 2 and 4? Yeah. What are the shape are those going to be? Parabolas, but opening down. Yeah, upside down parabolas. So here is your cosecant graph. Okay? Now, here is your sine graph to go on the same axes. There's the sine graph that fits in it. So sine, you learned back in the obviosities, lives in that -1 to +1 y value range, right? So cosecant can't live there because sine lives there. Okay? So cosecant has to live outside of that. Okay? What about tangent? Nope. Just because it was cosine and sine. Yep. Okay? So what I would like you to do now is I would like you to graph me cotangent and secant. Okay? Cotangent and secant. Go. Cotangent? The only reason I said it is because cotangent does come in. So really you didn't have a choice. Okay? See? So cotangent has vertical asymptotes at the whole number, at the whole pies. So -2 pi, negative pi, 0 pi, and 2 pi. Okay? And the waves are going opposite direction. Okay? The tangent waves started lower left, went to upper right. Lower left went to upper right. The cotangent waves start upper left and go down to lower right. Questions on cotangent? All good? Okay. Secant. Secant has vertical asymptotes at the pi's over 2's. Because that's where cosine is 0. Okay? If I were to put the cosine graph on here, it would look like that. Okay? So again, so since cosine lives between -1 and +1, that means secant also can't live there. Okay? Good?